In the last video we talked about the selection sort. We talked about this the sequential search algorithm. So in this video we'll be talking about the binary search algorithm. So the sequential search algorithm uses a loop to step sequentially through an array, starting with the first element. It compares each element with the value being searched for and stops when the value is found or the end of the array is encountered. If the value being searched for is not in the array, the algorithm unsuccessfully searches to the end of the array. The advantage of the sequential search is that it's easy. Furthermore, it doesn't require the data in the array to be stored in any special order. Its disadvantages, however, is that it's inefficient, so it has to, if there's 20,000 elements, it has to search all 20,000 memory locations in order to find the value stored in the last element. So basically, in an average case, an item is just as likely to be found near the beginning of an array as near the end. So typically for an array of n elements, the sequential search locates an item in n divided by 2 attempts. If an array has 50,000 elements, a sequential search makes a comparison with 25,000 of them in a typical case. That is assuming, of course, that the search item is constantly found in the array. N divided by 2 is the average number of comparisons. The maximum number of comparisons is always n. So it has to make, so the sequential search has to check all the memory locations. So it has to always check n memory locations. The binary search algorithm is more efficient than the sequential search. It only requires that the values in the array must be sorted in ascending order. Instead of testing the array's first element, this algorithm starts with the element in the middle. So if that element happens to contain the value, then the search is over. Otherwise, the value in the middle element is either greater than or less than the value being searched for. So it basically just checks if it's less than the half or greater than every time it checks the median value. So we'll just do a code example on the binary search. So here we'll just say private void binary search. Takes a parameter int array and an int val. So we'll have a local variable here. Int first points to 0. Int last points to array dot length. Actually, sorry, array dot length -1. We'll have a variable called int middle, and int position points to -1. We'll have a bool found and set it to false. We'll have a loop, so we'll say while not found. So while found points to false and first is less than or equal to last. Then we'll say middle points to first plus last divided by 2. We'll say if the array.length, sorry, we'll say that not array.length, we'll say if array of array index middle points to the value, points to val. Then we'll say found points to true, and position points to middle. We'll say else if, So else if the array of array index middle is greater than val, we'll say last points to middle minus 1. So I have another final condition here, and we'll say else first points to middle plus 1. So it's either going to be one of the blocks, else if, or else. So first points to middle plus 1. And at the end we have to return position. So this is a, actually sorry, is this, sorry, this shouldn't be private void, it should be private int, so we're going to return an int at the end. So we're going to return a number at the end, not a void, so that's why we have return position, so that satisfies the return type for this method. So that's pretty much it. I don't think we're going to step through it because it's, like I showed you guys how to step through it already in the debugger. You just set a breakpoint here and click the debug icon, and you can step through. So you can just create an array and a value to search for, and then just search for it. So I'll probably just end that one there. So thanks for watching, guys. If you guys like the video, you can like and subscribe to support the channel for more programming and investing tutorials. In the next video, we'll be going over two-dimensional arrays. Actually, we could just do two-dimensional arrays in this video. So we'll just talk about two-dimensional arrays as well. So two-dimensional arrays are they're like single dimension arrays, except they're like, we've done these in the notes already. So two-dimensional arrays have basically it's like a matrix in math. So a matrix has rows and columns. So we've already done an example, but we'll just declare one here. So the syntax in C# is a little bit different than Java and C. So we'll just do the, I'll just delete this method here. Okay, here for example, we can just say double, so it just takes an array block at the beginning. You just name it, for example, we could just call this double array of array index comma, and then we'll call it array points to new double. And here we'll pass in, for example, we'll pass in 3, 4, so that's going to be, I believe, 3 rows and 4 columns. So to declare a two-dimensional array, 2 size declarators are required. The first one is for the number of rows. The second one is for the number of columns, so rows and columns. You can think of it like X and Y. So you can see that there's a comma that appears inside the first set of array brackets. That's the syntax that's different. Usually in Java or C you'll just have that's what the syntax is here. But here in C# you have to include a comma in the first set of array brackets. So instead of passing in a size, we can declare 2 constants here, for example. So we can say constant int rows points to 3. And we can say private constant int calls points to 4. And then when we declare the array private double array of array index comma array points to new double, here we can pass in for the parameter of array index row rows comma calls. That's going to pass the values 3 and 4 to the two-dimensional array. So we'll just, I've already done this in the notes, but we'll just make this 2 and 2, just to show you. And then so here we'll just have a comment. So there's going to be so 2 rows. So, okay, so 2 rows is like that. We can, yeah, so there's just like that. I'll just put zeros here. So the first 0, so right here in the top left corner, that's gonna be row 0, column 0. And then it goes across first. So it goes, so then we look at row 0, column 1. Then when the column ends, it goes down to, so we'll debug this. We'll try to do an example where we can see this in the memory. So here we can say, so on the next line here, then we have row 2. So it's row 1. So let's just do this by indexes. Okay, so let's change these values to 1, 2, 3, 4. So for example, if we have this array called array, so we can say that array of row 0, column 0, or which is x and y, points to 1. The value is 1 at array index 0, array index 0 of array index 0. So then if we shift over to the right, so I'll just go, actually, let's just do that down here. So on the next index array of index 0, or row index 0, column index 1, because we're going to move to the next value. That value is 2. And you can see that the first row of array elements ends. And then on the next one, we'll say, so we'll go to the next row. So we'll say array of index 1, index 0. So that's going to be row 1, column 0, points to the value 3, because we moved down a column. Sorry, we moved down a row to the start of the next column. That's going to point to 3, and then for array index column 1, actually sorry, row 1, column 1, that's going to point to the value 4. So that's pretty much how it works. We've already done this in the notes. So we can also access the elements in a 2-dimensional array. So we can have 2 values here, same values is fine. We can change this array name to vals. And then for example, we could say that we want to store the value. So we could say vals of array index 2, 1 points to the value. So for example, we could just pick a value. So you can try this, or this. It might actually be this syntax, so we'll just do an example to check. So we'll create a random object here at the top. So we'll say random brand points to new random. So we have our constant int rows points to 2 and constant int calls points to 2. Then we have, so we'll just change this, the type to int of the array. So we'll say private int array index, array of array index, comma, vals points a new int passing in rows, so passing in index rows, comma, calls. Then in the constructor we can loop through, so we'll have a nested loop here for int row points to 0. Row is less than, actually we can just go with I, so we can say for int I points to 0. I is less than the constant rows. And then we can say I++. So that'll be the outer loop, and then we'll have an inner loop here for int j points to 0. J is less than calls. Call plus plus. Sorry. Capital calls plus plus. Actually, no, sorry, that should be j plus plus. So for int j points to 0, j is less than calls j plus plus, and here we'll have vals of array index. We'll pass in I comma j. So we'll say vals of array index I comma j points to ran.next, passing in the value 100. So it's going to pass in random values between 0 and 99. So let me just check. There's an error here. Let me just. Oh, sorry. I think I forgot the semicolon. There's one more. Let me just check where it is. Okay. Oh, sorry. So we'll change this type here to int. So if you try this syntax, I don't think it likes that syntax. So instead of doing the double array brackets here, just do one bracket and then pass in a comma instead. So we can just change these ones here. So we'll say for these, just for this array here for the example, so we'll say array of array index 0 comma 0 points to 1, and then for the next one we'll say array of array index 0 comma 1 points to 2. Then we'll say here array of array index 1 comma 0 points to 3, and then array of array index 1 comma 1 points to 4. I don't think we really need to step through this. It's just going to show that it's a 2D array. Same thing as this here. Actually, we could just do one step through. So I'll just set a breakpoint at this nested loop here. I'll just save it and then click the debugger. Okay, so sorry, it's just loading, one sec. Okay, so here we have for I points to 0, I is less than rows I++, so rows is going to be 2. So I points to 0, I is less than 2 I++, so it's going to iterate twice because it's just, so it's less than 2, so it's just going to iterate from, the first iteration is going to be 0, the second iteration is going to be 1. So we'll just step in here. So it's showing us that I points to 0 in our variables in memory. So we'll step in again. So now here it's for in j points to 0, j is less. So j calls is also 2, so it's j points to 0, j is less than 2, j plus plus. So once again, it's just going to iterate twice. So now it's showing us that I points to 0 and j points to 0, so we're on iteration. Remember, the inner for loop's going to iterate completely for every one iteration of the outer for loop. So we'll step in. Now it's telling us that the vals 2D array of array index I comma j, so we're going to pass in the values here. So vals of array index 0 comma 0 points to a random value between 0 and 99. We'll step over. So it doesn't show the array because it's a field. So I guess C# doesn't show the arrays in the fields in memory in the debugger. But basically, it shows us that the value 64. So we have the 2D array at array index 0 comma 0 points to 64. So we can just change that value there. We can just add that value here, 64. Okay, so we'll step in. So now the iteration for the j for loop, it's going to add 1 to 0. So it's for j points to 1, j is less than calls j plus plus. So sorry, did I say 0 or 1? So I said j. What I meant is for int j points to 1, j is less than 2, j plus plus. So now j is going to have its second iteration, which points to 1. So you can see that the value in memory changed from 0 to 1. So step in. Now we have vals of array index I comma j. So we'll pass in I. So the value for I is 0 and the value for j is 1. So the vals array of array index 0 comma 1 points to a value between 0 and 99. So the value is 99. So so array index 0 comma 1 points to the value 99, so we can change that here, and then the value here is also 99. So we'll step in. So right now vals is going to increment by 1. So it's going to point to 2, so int j points at 2. Is j less than 2? It's not, so the first inner for loop iteration becomes, so the first inner for loop condition becomes false. So it's going to skip this block back to the outer condition, and the outer for loop is going to iterate from 0 to 1. So now for I points to 1, I is less than 2i plus plus. You can see that I changed from 0 to 1. So we'll step in now. J is going to iterate again completely. And that process is just going to repeat again. So the value is 37 here for the next index for array comma, so the of array index 1 comma 0. Then j will iterate, it'll increment itself by 1, so j points to, j points to 1, j is less than 2, j plus plus, so we'll get another value for vals of array index 1 comma 1. So the value points to 89, so we'll pass in 89 for the last value. So that's the end of the outer for loop, because I I pointed to 2, so I was not when it iterated again, so 2 is not less than 2. Therefore this this condition becomes false, so that was the end of the loops. So that's pretty much just the first 2D arrays. So in the next video we'll be continuing with probably a longer lab for the 2D arrays. So thanks for watching, guys. If you guys liked the video, you can like and subscribe to support the channel for more programming and investing tutorials. In the next video we'll be continuing with 2D arrays. So thanks for watching. Hopefully I'll see you guys next time. Take care.